Welcome back to my channel. So today we are seeing this topic of nature of fluid and pressure concept. So just a recap here. The solids can permanently resist a shear force when they are subjected and move a short distance. Means when these solid substances are subjected to a shear force, means we are pushing them, so they will move a short distance. So it is also called as elastic deformation. This is a very important term, so just remember it. Next is by setting internal shear stresses and they stop moving. So these solids are having densely packed atoms in them, so they can resist this shear force very nicely. They can resist it, so they will move just a short distance and then they will stop moving by setting the internal shear stresses. So whereas the fluid is a substance that flows freely on continuous deformation. So fluid is naturally having, the atoms little bit loosely bound. So what will happen means it will flow freely, and on continuous deformation, it will also have no resistance and the shape will be changing here. So however small the shear force may be, the hence offers no resistance to shape change. So for very slight shear force also the fluid will flow. So there are two types of fluids. One is liquid and other is gas or the vapor. So liquids are incompressible and inexpansible. Means they cannot be, pressed and, made into minute or small compact thing. And expansible means neither they can be, made into a very large volume substance also. Okay, so they occupy a definite volume. See, the liquid will be always occupying some definite volume and a free surface. So however, hence they have a low or small coefficient of expansion and the working temperature range is also small. See, it cannot expand also, so it is inexpansible. It is having very small range of expansion coefficient, and whereas it also has this small temperature range. Working temperature range is also small, so hence it is incompressible and inexpansible. See, when it comes to vapor and gases which are compressible to any degree, because naturally they are having the atoms which are freely bound, means they move in all the directions. They do not have a definite shape or volume. Okay. So the term vapor here is for a gas when it is at a temperature below the critical temperature of a substance. Means there will be a substance, like example is a water, which is a standard example. When this type of substance is having a temperature below critical temperature, then it is called as vapor. That gas is called as vapor. Okay, see, note point, please note this properly. It will be always used, and you never know when these note points or definitions will come for use. You will definitely going to be using these things, so I am going to explain this, and I am stressing here for that reason only. See, first, gas can be liquefied by reducing the temperature and increasing pressure. When we reduce the temperature and increase the pressure, then only these gas can be liquefied. In liquid form it will be obtained. So this temperature below which a gas is liquefied is called critical temperature, denoted by Tc. Okay, so I hope this is clear. Next is pressure. It is a compressive stress as force per unit area and given as P is equals to F by A. So pressure is a compressive stress. What do you mean by compressive stress? Which wants to compact, okay, anything, putting pressure from one direction to make it suppress, compact. So that will be force per unit area, and this is the formula. So in a stationary fluid, the compressive force per unit area is same in all the directions. But in a solid, it is not same in all the directions because solid is a densely packed substance. So I hope this much you have understood. The same video will be coming in Kannada version and we will be completing all these things, definitions, and then we will be proceeding to one of the important derivation. Okay, I will tell it. The main point is any fluid is there, it is depending on temperature and pressure. So how the temperature and pressure will act, that makes a very big differences for these fluids and their flow. I hope you have you are understanding all these topics. Okay, thank you.